For the past decade, astronomers have been inching ever closer to answering the most puzzling question: what is the origin of the mysterious, high-energy, radio signals that ping Earth, and then, more often than not, vanish without a trace? All sorts of theories have been proposed to explain these fast radio bursts, or FRBs, aliens, because of course, exotic physics, extremely magnetized stars. There's a laundry list of potential explanations. In November 2020, a suite of papers in the journal Nature announced the discovery of the first FRB emanating from our home galaxy. That detection implicated magnetars, an unusual type of dead star, as the cause of the millisecond bursts. However, the connection has yet to be definitively proven, and so astronomers keep on searching. In a new paper, set to be published in the Astrophysical Journal and available as a preprint on RZIV, observations with NASA's workhorse, Hubble Space Telescope have helped researchers to pinpoint the location of 5 FRBs to the spiral arms of distant galaxies. The team looked at 8 FRBs, most of which were first detected in 2019 and 2020, but the locations of 3 of them remain enigmatic. This is the first high-resolution view of a population of FRBs, said Alexandra Mannings, an astrophysicist at the University of California, Santa Cruz, and the paper's lead author. NASA's Hubble was a critical component in the search. FRBs ping Earth-based detectors like the Australian Square Kilometre Array Pathfinder, which allows them to be tracked to a region of the sky. Further imaging of the region might uncover a galaxy there, but they are only tiny points of light. When Hubble steps in, the resolution is increased enough to study the features of the galaxies. In this case, Hubble either confirmed the presence of spiral arms in these galaxies or uncovered spiral structure we had not been able to see before, said Wen-Fei Fong, an astrophysicist at Northwestern University and co-author of the study. The study helps to refine our understanding of these unusual, energetic outbursts and rule out some possible sources. The galaxies that many of the FRBs have been localized to are massive, relatively young and still forming stars, according to Mannings, providing valuable context for FRB researchers. But the spiral arms of a galaxy don't typically house huge numbers of the youngest, brightest stars. Finding the FRBs there helps rule out 2 causes. They're likely not coming from explosive star deaths, which take place in the brightest regions of galaxies. Nor are they caused by neutron star mergers, which can take billions of years to occur and aren't commonly found in spiral arms. The localizations don't rule out one of the leading theories of FRB production, magnetars. These stars throw off super-powerful magnetic fields, and it's believed this can cause a radio flare to be thrown out into the universe. If you're listening, like many of Earth's ground-based telescopes, those flares can be picked up. There's still a possibility that some of the FRBs detected on Earth are caused by something other than magnetars, but the evidence seems to be stacking up in their favor with each new study. Not many FRBs have been traced back to their home galaxies. Some bursts have been known to repeat, which has helped Astro Sherlocks get a lock on their location, while others just flare to life, leaving only a ghost of a signal and requiring a little extra detective work. It's unclear, at present, if all FRBs repeat or just some. There are a lot of intricacies to explore once we have higher numbers, said Mannings. It's a really new, exciting field with limited observations, said Fong. We're paving the way to learning more about this cosmic mystery. As the number of FRBs discovered continues to rise, astronomers are beginning to understand them a little more. They're even helping us look at the universe in exciting new ways. In May 2020, astronomers in Australia used them to solve the universe's missing matter problem.